Good morning, geometry. Today we're learning about 4.7, more equations of lines, and we're talking about point-slope form. So in your notes, here we go, equations of lines. Point-slope form looks like y minus y1 equals m times x minus x1. Now remember, x1 and y1, these are x and y values of a point given, and this point passes through the line. M is still the slope of the line, which we can find using rise over run. Sometimes they give it to us, or we can use our y2 minus y1 over x2 minus x1. So it's really nice when we're trying to write the linear equation in slope-intercept form. Whenever we're given a point and a slope, that's when we use this, hence the name point-slope form. So in example number 1, I was given the point 4, 1. 4 is my x1, 1's my y1. The slope, 2, is our m value. When I plug it into the equation, we get y minus our y1, which is 1, equals 2 parentheses x minus our x1, which is 4. To simplify this, we really need to be distributing. So we would distribute the 2 to both things in parentheses. Bless me. So 2 is being distributed to x. That's how we got 2x. And 2 times negative 4 equals negative 8. Last step, to get y by itself, to make it look like slope-intercept form, y equals mx plus b, y equals, we add 1 to both sides. And I add it to the thing that does not have x, because those are the like terms. When I add 1, I get negative 7. So our final answer is y equals 2x minus 7. Okay, for number 2, again, our point this time is negative 8, negative 1. So that's our x1, y1. Our slope is negative 3/4. So when we plug it in, we're going to get y minus a negative 1. Well, minus a negative we know really means we're adding. So it's going to simplify to y plus 1 equals negative 3/4 times x minus, again, minus a negative means we're going to be adding. So when I distribute this time, I'm distributing negative 3/4 x, and that doesn't simplify. But negative 3/4 times 8, and remember it's a positive 8. When we type that in our calculators, negative 3 times 8 is negative 24. Divided by 4 is negative 6. So that's where this negative 6 came from, multiplying. Last step, we want to get y by itself, so we subtract 1 to both sides. When we subtract 1, it cancels on the left. We're left with y equals negative 3/4. Negative 6 minus 1 is negative 7. Final answer. So it's really nice whenever they give us the slope. They're not always going to be that nice though. Sometimes we need to be able to calculate the slope. So they still give us a point. And in this case, they actually give us 2 points. And we want to write the linear equation in slope-intercept form. So they give us a point. They actually give us 2. To find the slope, we have to use our m equals y2 minus y1 over x2 minus x1 that we've been drilling hard the last week or so. So to find our slope, we plug it into that formula, and we get negative 1 minus 7 on top over 1 minus negative 3, which really means we're going to be adding 3. So on top, negative 1 minus 7 is negative 8. And on bottom, 1 plus 3 is 4. So this actually simplifies to negative 2 for our slope. Well, that's not all there is. We want to write the linear equation. So now that we have the slope, we plug it in. We plug in our points as well. So since I already have negative 3, 7 as my first point, my x1, y1, I'm going to use those to plug into the equation. Y minus y1, which is negative 7, equals negative 2 times x minus negative 3. Again, that's going to mean we're actually going to be adding in there. So in the parentheses is addition. It's a positive 3. when we distribute negative 2 to both things, we get negative 2x. Negative 2 times positive 3 is negative 6. And last step, add 7 to both sides. Get y by itself. So y equals negative 2x plus 1. Final answer. Okay, one more example of this where we have to solve for y. So they give us 2 points, x1, y1, x2, y2. We first need to know, well, what's the slope, because the name is point slope form. So I plug in to y2 minus y1. Negative 4 minus a negative 7, which really means we're going to be adding 7 on top. And on bottom, 3 minus negative 6. Minus a negative again means add. Negative 4 plus 7 is 3 for the top of our fraction. And 3 plus 6 is 9. This fraction does simplify to 1/3. Our slope is 1/3. And we're going to use, again, the same points, x1, y1. When we plug those in to slope-intercept form, we get y minus negative 7. Which really means we're going to be adding 7. Equals 1/3 x minus negative 6. Again, it's a positive. When we distribute, because we have a number next to parentheses, we get 1/3 x. And 1/3 times 6 is positive 2. To get y by itself, we have to subtract that 7 to both sides. Y equals 1/3, and 2 minus 7 is negative 5. So the reason we always solve for slope-intercept form is that's the form of the equation that we use for graphing. That's the form we can interpret the slope, the y-intercept. It's the most useful. But from the information given, we didn't have enough information. We didn't know the slope. We don't know the intercept. So we have to use a different form, point-slope form, to solve. But really, the big idea and what we've been doing and working on is parallel and perpendicular lines. So 5 and 6 are talking about parallel lines. If I want to write the equation of a line that is parallel to x minus 3y equals 9 and passes through the point 3, negative 1. Well, first we have to remember parallel means that they have the same slope. So if this line, x minus 3y equals 9, I need to know what is the slope. What's the new line going to be the same as? So I solve. I start by subtracting x to both sides, because by subtracting x and canceling, I'm trying to get y by itself. When I subtract 9 minus x, though, it does not simplify. So what I end up getting is negative 3y equals negative x plus 9. Again, y is not by itself, so I'm dividing each piece by negative 3. A negative divided by a negative is going to be a positive in front of that x. And then our last point, 9 divided by negative 3, is still going to be a negative. Our final answer is y equals 1/3 x minus 3. That 1/3 I put in red, that's because that's our slope. The number in front of x, our m. So if I want a line parallel, I want the same slope. I want the line to have a slope of 1/3. And now we're going to use that point they give us. It passes through the point 3, negative 1. Once I know the slope, I have a point, plug it into point slope form. I get y minus negative 1, which really means add 1, equals 1/3 x minus 3. We distribute 1/3 to both things. I get 1/3 x, and 1/3 times negative 3 is negative 1. To get y by itself, subtract 1 from both sides. And we get 1/3 x, I forgot my minus 2. So y equals 1/3 x minus 2 is our final answer for our equation of a line parallel to the equation given. Let's do one more of those. So if I want to write an equation of a line parallel, so it has the same slope as 6x plus 5y equals negative 10. I start by solving that equation. To get y by itself, I've got to start by subtracting 6x to both sides. By doing that, I am canceling the x's on the left. So when I subtract 6x, I'm left with 5y equals negative 6x minus 10. Y is not alone yet, so as you can see, I'm dividing 5y to each piece. It only simplifies in one of the pieces though, because when we take negative 6 divided by 5, that does not simplify. That stays as negative 6/5 x. But negative 10 divided by 5 becomes negative 2. So our final equation is y equals negative 6/5 x minus 2. This is the original line. The slope is the number in front of x, negative 6/5. If I want a line parallel, I want it to be the same. So again, I plug in that slope and the point they give us. In this case, it's 10, negative 9. And that 10, negative 9, negative 10, is our x1. 9 is our y1. Plug it into point slope form, and we get y minus 9 equals negative 6/5 x plus 10, because it's minus a negative 10. Distribute that negative 6/5, and we get negative 6/5 x minus 12, because negative 60 divided by 5 is negative 12. And then last step, add 9 to both sides. So y is by itself. Well, when I add 9, I'm left with negative 6/5 x minus 3. So that is our new equation that is parallel to the original. And I can see that because the slopes, negative 6/5, negative 6/5, are the same. Okay, when you're ready, click the video below. There's one more to go to finish up the last 4 examples.